Good morning, everybody. And as Adele said, welcome very much to our April webinar, Discovering the Magic of STEM. Today's going to be very exciting because we have some live experiments. And I just wanted to introduce you to our guest speaker. Sandra's ready and raring to go. So I've just spent a couple of minutes introducing her and letting you know what she'll be covering today. So this is going to be a fun interactive session, and over the next 20 minutes or so, Sandra is going to reveal some simple child-led ways to bring science to life in your setting. And this will include some easy experiments that fit into everyday play, why STEM matters and how it supports learning, problem solving and creativity, and letting children explore at their own pace through child-led discovery. But first, a little about Sandra. A mum of three, Sandra's fascination with STEM began when her middle son was just 9 months old and he's now 10. And what started as fun experiments for her baby quickly grew into a wider initiative after friends were amazed that a 9-month could actually be engaging in science activities. She's the author of 50 fantastic ideas for STEM activities. She's been featured on BBC, BBC Radio, BBC Breakfast, and in local and national newspapers and magazines. She was nominated for the STEM Initiative of the Year and the Cambridge Science and Technology Awards in 2023, and she is a BBC STEM freelancer, delivering STEM workshops as part of the BBC's STEM season. So without further ado, over to you, Sandra.
Hi everyone, hello. As Gail just introduced me, I am Sandra Beale. And I am the founder of Toddler and Early Years STEM. I started my STEM sessions when my second son was 9 months, just to entertain him. And it just grew because people were amazed at a 9-month-old baby doing science experiments, and they wanted their children to participate. I think it is actually quite incredible because it's 10 years of toddler STEM this year, and I've been doing STEM sessions in my house twice a week for the last 10 years, and I've come across a variety of young children from age 4 months to like age 6-7 years old, and they are so amazing. Each child is each child is so they're so bright and so clever, and you can see how much science is so important in the sense that it offers them everything that they need. Like, children are very curious, as you probably know if you've probably come across young children. And
Sandra,
yes,
I'm so sorry to interrupt you. I know you're going to do amazing experiments, but I don't know if you're where your camera is off.
Okay,
so
I've turned it off and I'm going to turn it back on again. Can you see me now?
Yes.
Oh,
yes,
brilliant.
Yes.
Oh, awesome. Coolio. Right.
Fantastic.
So where was I? Yes, I was telling you all about the children who come to my STEM session. So I've had very young children from sort of 4 months, so that's 16 weeks, and this particular 16-week-old baby who's sort of come along with the STEM sessions, she's just turned 2. She is so brilliant. It's amazing. She sort of anticipates the next step in an experiment, which is really incredible, and it just shows how much children actually absorb at like quite a young age. So one of the examples that I'll give you is that I do a hovercraft experiment quite often with the children, and when I was writing my book, I put the hovercraft experiment in sections on the table for all the children to do. And so I don't know if you know the hovercraft experiment. It's just it's a CD, and it's a bit of blue tack, and it's a rinse aid bottle cap and a balloon. So I just put it all out in front of her and in front of the other children, and she actually picked up the bottle lid cap and she was trying to attach it to the CD, which is quite incredible. And this was when she was about 18 months, and she was trying to do that, which is amazing, right, for that kind of age group. And of course her mum was a bit like, wow, this is incredible. But I've noticed in all the children who've been coming to the sessions, and if they keep coming to the sessions, they start to they start to take ownership of the experiments, and that is exactly what I want. I want them to take ownership of the experiments. I want them to be proud of what they're doing, is because all I'm doing is just sort of showing them that, you know, how much science, you know, is around us. And it's you know, we're pretty much surrounded by science, and all I'm doing through my experiments is just letting children enjoy it and getting into it and having fun. And it's a lot of mess, a lot of chaos, and a lot of you know, all sorts of things that keep happening. But at the end of it, the children enjoy the sessions, and the parents enjoy the sessions. And I've had lots of parents come back to me and say, oh, we didn't know that, and we didn't realize it can be so easily done, and we didn't realize that, you know, you're just using household materials, which is, I think, quite important, because I've been doing STEM sessions at our library, and the library lady, she's actually made a box of STEM material for me. So she puts in all sorts of bits like bottle caps and balloons and various other bits and pieces, because you can make use of all these things for various experiments. You don't have to kind of go and spend like bucket loads of money on equipment. It's, you know, it's not something that can be done in a house with like 4 balloons and a bit of bicarb, for example. So I mean, basically what I'm trying to say is that everyone can do science experiments with their little ones, and babies, that, you know, they are so bright. They're born with that inquiring mind, you know, they just want to kind of find things out, and science gives them that. It gives them that ability to kind of just explore and just discover and play, and children learn through play, which is incredible. I mean, I love it. I love what I do. I mean, I started off on, you know, as you know, on my own initiative, just to entertain my own son, and my children, they sort of say they don't like science very much. Of course, they've had a lot of it, but they're very good at science in school. In fact, when my second son started reception, he started using words like buoyancy and various other words. And his teachers were like, what? How does he know what buoyancy is? And he was 4 years old, and he actually told them what buoyancy was. And they were absolutely astonished. And they found that other children who'd come to my sessions were also using similar words, you know, like magnetic suspension, buoyancy, etc. And they were quite amazed, and they were like, how on earth are these children using these words? Because you don't expect a 4-year-old to use and understand the meaning of these words. It does help with language skills, etc., which is great. I mean, when I'm doing sessions with the children, I talk to the children the same way I would talk to anybody. I don't sort of, you know, sort of baby talk them. I talk to them like I would talk to anybody. And I think that actually helps, because then they learn words. They learn the right words for you know, for the experiments. They understand, like, you know, they understand things like carbon dioxide. You have like a 2-year-old saying the words carbon dioxide, and people are like, what did she just say, carbon dioxide? And it's like, and a child understands. She understands that if and I've shown children how leaves breathe underwater, which is another amazing experiment. You just take a bowl of water, stick a leaf in it, put a little pebble on the top of the leaf so it sinks a little, and then watch the bubbles. And the little bubbles that come under the leaf is because it's breathing underwater. And it's incredible. It's just simple things like that, which open a child's eyes, and a child can see this is magic. It's literally, but it's science. I mean, you know, it's scientific magic or whatever, I don't know, but it's absolutely incredible. It's like even pine cones, for example. If I mean, I don't know if you know what happens to a pine cone when you put it in water. What do you think happens to pine cones? Does anyone know?
Does it float?
It's any others? Anyone else?
Sarah Westbury says, does it open up?
No, it doesn't open up, but it actually,
does it close?
It closes. Yes, it does. It goes to sleep. It goes to sleep. It closes. So this is one of the experiments that I do, is to put a pine cone to sleep, and you put it in water, leave it for like about 5 minutes, and you'll see, you know, the pine cone just completely closing. You take it out of water and you leave it out for, or you can dry it with a hairdryer, and it opens up. And that's quite amazing, because you can see it happen. And the reason it happens is also because, yes, it does shrink. It shrinks a bit in water. And it's not actually shrinking in that sense. What it does, it's closing up. It's all the little you know, the piney bits just kind of they just close. And in nature, the reason it does that is to protect the seeds, because, as you know, pine cones are full of seeds, right? So it's just there to protect the seeds. So every time it gets really cold or wet, you'll always find a pine cone that's closed up. And then, of course, in the summer, when it's warm and sunny, the pine cones burst open. And that's all that I'm trying to show the children. And it's part of one of the nature sessions that I do with the children, which is amazing, and kids love it. And I go even further sometimes to get them to stick paint on the pine cones and then roll the pine cone on paper, just kind of like toss it. And I do it outside, actually. And they just toss the pine cone across paper, and it looks amazing. There's the colors that come out on, you know, just with pine cone painting. So you can kind of start off with an experiment, and then you either you can just let it, you know, just let it run. You know, you can see what happens to it. It is actually quite incredible. And sometimes the children come up with their own ideas. We had a little boy who'd been coming since he was about 2, and quite recently, just before he went to school, he did an experiment with me. I was doing this the catapult, where, you know, with craft sticks, and we were pinging pom-poms through hoops, and I said, okay, we'll have these little hoops on the table. And then he was like, can we try a different way? And I said, yes, of course, you can try whichever way you want. So he took a magnetic wand and turned and used a hoop with pipe cleaner, and held up the magnetic wand with the hoop at the bottom, and then was pinging pom-poms through the hoop, which was brilliant. I mean, that was his own you know, kind of way of doing it. And I just thought that was really amazing, because it turned out to be much better than what I wanted to do. And I just love how children just kind of take ownership of their experiments and, you know, run with it, which is really what I want them to do. I want them to kind of be able to solve solve situations, and be able to think out of the box when it comes to problem solving, etc., etc. And that's the whole point of my sessions, really. But yeah, I mean, if you have any questions, you can ask me. But I've got some experiments that I'd like to show you. There's a few session experiments, but if you have any questions, do feel free to ask. So with this experiment, very simple. You need a magnetic wand. Can you see that? Can everyone see the magnetic wand?
Yep.
Right.
Yeah.
A paper clip. Can everyone see the paper clip?
Yes.
Yeah. And then I've got a string attached to the paper clip. Yes. So I'm just going to stick my finger down onto the table like this. And then I'm going to lift. It works a bit better if I use some sellotape. So just bear with me a second while I grab some sellotape. Scissors, and obviously you must remember never to give a very young child scissors. And I'm sure everyone knows that already. So, but I just thought I'd just say it just in case. So, right, just a little bit of sellotape. You stick it to your table like that. And then you lift up your wand. And can you see that?
Yes.
Can you see that it's actually hovering? Can you see it hover?
Wow.
Maybe if I use that as a background, you might be able to see it better. Can you see that? Can you see it hovering?
Yes.
There we are. So that's magnetic suspension. So what you're actually doing is you're suspending this paper clip in thin air, and if this experiment's worked, then you can actually run your finger through, and and it won't break the magnetic pull. And it's a really simple experiment. Paper clips, string, everyone has those. Magnetic ones, you could get them anywhere really, and these ones are learning resources, magnetic ones, but you can get them from anywhere, from Amazon or eBay or wherever. And most early year settings have magnetic ones, and or magnets, for example. You could even use one of those horseshoe magnets that it would work. It's just the reason I use this is because it's just easier for small children to hold, and because it's got a handle, etc. Anyway, so that was magnetic suspension. Of course, you can take it further by so I've done we did a Harry Potter themed session a while back, and I got the children to levitate.
Oh, I think Sandra just pressed the wrong button and has left us again. Apologies. That was really exciting. I looked at the note. Someone just said they've done something similar for Halloween. I love the idea of the spooky ghost theme. I think children will really enjoy, but I love the creativity that's already come through. I've asked Gail to see if we can enable people with the mics so that you guys can actually be a bit more interactive. Fantastic, Gail. So you can now put your mic on if you wanted to share some of your ideas just while we wait for Sandra to join us. But yes, I think the spooky Halloween one, you could even probably do something like someone else said they've done a butterfly one, paper clip in the shape of a butterfly, so it looks like the butterfly is flying. I love that.
The person that did the butterfly one, do you want to take yourself off mute and tell us how you did that? That one looks really interesting. Sharon.
Hello.
Hi, Sharon.
Hi, Sharon.
Hi. It's the same as what she's already done. I will let the cameras off. Same as what she's already done, but putting a tissue paper shaped butterfly on the magnet. So you stick it either side of the magnet, put butterfly on the side, hold the magnet above, and it'll fly up as it magnetic pulls the force up.
That is pretty cool. I've done that with feathers. I've done it with a feather for like an Easter theme thing, and we've done like levitation as well, which is actually quite fun. So you just kind of, it's the same thing like you just mentioned with butterflies and things. And I've done it with feathers, like in Harry Potter with where they have this
Wingardium Leviosa.
Yeah, that's the one. Yeah, that's the one. So yes, I've done it with that, and it's actually quite fun. Just stick a feather to the clip, and it actually levitates, which is actually quite fun. So that's magnetic suspension. So so I'm going to do another one, which is the center of gravity. So for the center of gravity, does anyone know what how to find the center of gravity with a craft stick?
Are you putting it on something round and wait until it balances?
Yes, absolutely, Adele. You're right. So we're going to use a craft stick. So you could try doing it just by asking the children if they can balance a craft stick on the tip of their finger. You get them to try it, and of course, what would happen? It would fall over like that, right? So then you attach some pipe cleaner to just wrap it around at the bottom, and so you've got that. Can you see? Can everyone see this?
Yep.
Yeah, and then your little paper clips. Not paper clips. Clothes pegs. You could use bigger clothes pegs. I just got small clothes pegs. So it should, if I manage to find the center of gravity, it should just balance on my finger. See?
Oh.
Does everyone see that? Maybe.
Yeah.
Amazing. Oh my god.
It's fantastic.
Yeah.
So you can, yeah, sure, go ahead, Gail.
Yeah, can I ask you? It just what you're doing is really amazing. And how about just I wanted to ask a simple questions. Do you know when you do this experiment?
Yes.
So I wanted just to know if the children, because as you said, they're young, and then all that
Yes.
was big words for them.
Yes.
Some of them. Yeah. Is there any things where they can link it to their, to when they're exploring the world? So, for example, the first one, when you did the magnet, the suspension,
Yes.
so that one, can they have any examples around them on a daily basis, where they can link that example, what comes around them when they're exploring the world? So, a
Um.
simple example, do you,
Yeah,
or
yes.
of course, we as adults, we can see what's
Yes, exactly. Yes, as an adult, you can actually you can pick out examples in the natural
figuring
world
out.
around us.
Yeah.
But for young children, in all their play and all the things that they do, they then experiment themselves. They start to look around. So if you show them something like this, for example, then they will start to experiment on their own. They will start to look around, because what you're actually doing is you're opening their eyes to different things around them. And children are they're so capable. They're so, they have that ability to sort of go
Oh,
from one thing to another very fluently. They don't, they're not like grown-ups where we are sort of quite stuck in our ways, but children, they just are very fluid in their understanding and in things that they do. And so if you show them something, they are bound to then extend it to something else. And I mean, I've seen it many times with the children who come to my sessions. Like, we start off on one experiment and we end up on something completely different, and it has nothing to do with me, nothing whatsoever. It's the child, it's the children who've taken it and decided to do other things with it. And I've done sessions
okay.
in nursery nursery settings. My children went to the Montessori in Saffron Walden, and I've done sessions with the children there. And some of the times where I've started off an experiment and I'm like, okay, I'm just going to let them carry on, because I find that things that they do is far more interesting than the stuff that I've tried to show them. And that's it, because for me, I'm learning too. It's not just, it's a two-way thing, where you show a child something and that child just takes it and runs with it, and that's the best thing. You just let them go free with an experiment, or with with anything, and they find their own way. They find different things that might solve a different problem. It's so incredible. It's so eye-opening for a grown-up. um there was an example with one little boy who used to come to my sessions when he was quite young. He was probably about maybe 13 months, or maybe a little younger than that. And he used to just watch the experiments. He never really kind of got into doing it, but his mother used to keep bringing him. And then suddenly he just started doing the experiments all on his own, just like that. He started coming to the table, and it was because he was sitting there and he was absorbing everything. Like, children are like sponges. People think a child sitting there is doing absolutely nothing, but that's absolutely wrong. They're not sitting there doing nothing. They are sitting there taking everything in, and then they do it. It's the same when children. I've had children who were non-verbal initially and have come to my sessions, and I've done sessions with them. And then one day they start speaking to their parents, and their parents go like, all they spoke was about science. And things like that are just amazing, because that their brain is working. Their brain is working constantly, and all that I do, and anyone who works with children, all we're trying to do is to build their brains. We're just doing that. We're just putting that added little thing here or there, and they're doing their own thing, and it's just amazing. It's just, yeah, it's exactly as someone just said about imagination. That is what it is, because children have imagination that's beyond, a grown-up's imagination. They come up with the most amazing things to say and do. And yeah, so I hope that answers your question to some extent.
Yeah, I just
Yeah,
wanted
yeah.
to add something as well that someone said in the group. It seems like these are for older children, but I think you can apply to the younger kids. It's like you said, they're just sitting there, they're looking at it, but sometimes the penny just drops, and actually then they start actually applying that. And Sharon mentioned forces. That's quite an interesting concept, but how you can bring science with and using forces like with water running through, for example, a little propeller, and how that actually you can generate electricity. Obviously, they won't understand that concept, but it's actually just developing their brain, isn't it? Or using a wind with a fan and putting them in front of it, or putting flutters of their, like maybe tissue paper or something. It's just understanding those little concepts and developing their brain.
Yes, absolutely. I completely agree with that. I know I've had parents who say, "Oh, my child is too young," or they're too this or they're too that, and I was like, no. If a child is born with a lot of, they are ready. They're born ready to kind of explore the world. That is how I look at it. And I've tried it with my own children. I've seen it with other children, and my book has babies in it, like all the children in my book are sort of under the age of 12 or 13 months. Of course I've got some of the older children too. I mean, each stage takes a different they take different things from the experiment. It's like even with grown-ups, each at a different time in your life, you take something different from what you're being shown, and it's the same for children. So a child who sees an experiment with water, for example, as when they're babies, they're like, okay, this is water, this is fun. As they get older, then they add to it, and that is what it's all about. You kind of you're showing them stuff. You're saying, look, this is what's available out there. You can be doing this if you want to do it. You can do it now. And then as they get older and as they understand a bit more, they carry it on. They take it on to a different level altogether, which is, I think, is quite incredible. And to actually see, it's like it's a metamorphosis. It's like you have this caterpillar turning into a butterfly right there in front of your eyes in terms of these young children. And I'm always fascinated when I see these kids, who and also my sessions are very child-led. So when a child comes for the first time to the house, sometimes they want to go and play with all the toys, and it's like, yeah, go and play. Then they kind of sort of dip and dive. Sometimes they come, they go like, okay, we'll take part in one experiment, we'll go and play, and then come back again. And it's all fine. It's all very child-led, and that's a great way of children getting used to a situation. Children being able to play and enjoy, and once they're comfortable and happy, then there's so much that can happen. It's just it's amazing. Anyway, shall we move on to another experiment?
Yes,
so
I'm excited already.
So this one is called traveling water. So can you see that glass? And there's a string in the glass. Can you see that?
Yep.
Okay. So that string is, I actually use wool when I do traveling. Does anyone know what I'm going to do with traveling water?
No.
Okay.
Float and floating objects, something like that.
Yes. So what I'm going to do is I'm going to get the water to travel down the string. So I'm just going to put a bit of food coloring so you can actually see what I'm doing. So just put a drop of food coloring in the water. Can you see it better now?
Yeah.
Okay. I've got another glass here, and I'm going to just make sure that the string is soaked in water, and then I'm going to get the water to travel down the string. Can everyone see this?
Mm-hmm.
Yep.
So can you see that? Can you see the water traveling down the string?
Oh, wow.
There we go. So can anyone tell me why that happened? Does anyone know? What?
No.
Anyone? No? Right.
Is it
No.
saturation?
To some extent. So this is wool. This is a string. This is wool, right? So one of the reason I used wool is because someone just mentioned saturation, which is a very close to what I was going to say. So water has something called hydrogen bonds. So the reason water is the way it is because of hydrogen bonds. And so when I explain it to very young children, I explain it to them as the water molecules are hugging and one another and coming down the string. So water is adhesive. So water will follow another drop of water. If you looked at it under a microscope, you'll see a drop of water clinging onto another drop of water, and they sort of like attach and they stay together. So which is why you have these bonds, hydrogen bonds, which are hydrogen means water, hydrogen and oxygen, and the water bonds. So of course, when I'm explaining it to a small child, I will talk about terms that they would understand, like hugging, but I will use the words hydrogen and hydro bonds. But I will explain to them that it's actually hugging the string. So when it comes down the string, the water is actually hugging other water molecules, and they're all hugging and coming down the string like that, which is why it doesn't splash. Now, if you didn't have a string in there, or if you had a dry string, for example. Okay, do you want me to do it again? Should I just show it to you again while I explain it? Let's do it again. So pour it all back in there. Yeah, can everyone see this?
Yeah.
I put the string back into the water, so it's thoroughly soaked. Now, if you had a dry string, what do you think might have happened when I poured the water?
It was splashed.
It would, yes. It would go everywhere. It would go everywhere. Yes, exactly. A big mess.
It wouldn't travel down the string.
Yes, it wouldn't go down the string. So now we're going to do it again. So can you see this?
Mm-hmm.
Oops. There we go. Can you see it?
Yeah.
Can you show us the top cup to see what you're doing? Can't see the top cup.
Yeah. Can you see that now?
Yes, lovely. Thank you.
There.
Basically,
it's pouring down the string, just following the rest of the molecules on the string, and it's just coming down into the glass below. And it's quite a fun experiment for children because it's visually very interesting, and they can see something happening, they can see it happening, and then children love doing it on their own. You get them to do it and they do it themselves. I've had very young children, like a 1.5, 2-year-old, and these glasses that I use are plastic, so there's no, it's not going to break or anything. And I never use a lot of water. I use a little bit of water. So even if there's a big spill, and I use trays, so the spill goes into the trays. But yes, any questions on these?
There's some questions already. So people have asked, have you taped the string into the pouring glass, or have you stuck the string to the bottom of the one with the glass?
It's stuck with can you see that, with gaffer tape?
Yeah.
It's stuck with gaffer tape. I mean, it's best to use really strong tape. If you don't have really strong tape, you can use sellotape, or you could just even use your finger and hold the string in place with your finger like that. Can you see what I'm doing?
Yeah.
So let me just demonstrate again so you can see. So if this is in case you don't have gaffer tape or you don't have sellotape or whatever, it'll still work. You put the string in there, and then hang on, there we go. Can you see?
Yeah.
I've just put my finger in there.
Brilliant.
So it'll still work. And I usually use food coloring in everything that I do, simply because children love color. It brightens up things. It makes things look much better. And also it's more visible instead of just using plain water. Okay, so should we do another one?
Yes, please.
Okay.
Please.
So, okay, we've got, this is a jar of rice. This is ordinary rice. So does anyone know what I'm going to do with this?
No.
So I'm going to lift this jar of rice with a pencil. Do you know how I'm going to do that? So this is an experiment on friction.
No.
There's just a pencil and it's a jar of rice. So what I'm going to do is I'm going to stick the pencil in first to show you that it's not stuck or anything, and then pull it out, right? You can see it's been pulled out. Yes? So now what I'm going to do is I'm going to press the grains of rice down. So it's tightly packed. It's going to be tightly packed around the pencil. And so we're creating friction. So what happens is that the grains of rice interlock around the pencil.
Wow.
And now, can you see that?
Oh, wow.
Can you see? I've managed to lift the jar of rice with a pencil.
Hmm.
Can you see that?
Yeah, it's good. Really good.
And then you just take the pencil out. There we go. And it's quite a simple experiment again. Rice, and or you could use other things really, like you could even use porridge if you don't have rice, and of course a pencil and a little jar. You could use, I mean, this is just a spice bottle, so I think most people have spice bottles. So yeah, it's a very simple experiment that can be done. Any questions on this one?
I have a question, Sandra, on that one regarding the rice.
Yes.
You said you could use porridge. Is there anything else you could use? Does it have to be a specific consistency or ingredients? Like, would it work with sand, for example, or not?
I don't think it would work with sand, because I'm not sure. I've never tried it with sand. I mean, you could try it, but I'm not sure if it would work. The thing is, why I use rice is because rice actually interlocks because of the grains of rice, and it has to be dry rice, obviously not cooked rice. So the rice grains, as you can see, what they do is, if you looked at it under a microscope, you'll see that when you press them down, they start to interlock, like they go like that. Which is why it sort of interlocks around the pencil. So all you're doing is you're creating this massive friction around the pencil. That's all you're doing. So that when you lift up the pencil, it's kind of the rice is so sort of it's surrounding, it's got so tightly packed around the pencil that the pencil cannot move anywhere. So which is why you can do that.
Wow.
Sarah Baker has asked if you can do it with lentils as well.
I think you could. Yes, lentils might work quite nicely, because lentils are also sort of grains, aren't they? They're sort of like I mean, obviously they're not the same sort of type, but yes. If you can do porridge, you can do lentils as well. You could do it with anything that's sort of small and slightly pointy, and I've never tried it with sand, but I mean, you know, that's another experiment, because you know, you can always experiment with things. That's the whole point of experiments, right? So, so you can experiment with anything. But yes, so that's lifting a jar of rice with a pencil, which is actually quite a fun experiment, and kids, when they do it, they get so excited, because it's very magical for them. But there's a reason, there's a scientific reason for it. So yes, any questions?
I think the brilliance of what you're doing is that, like you said there, you can try different material and then actually then let the children, develop their own kind of understanding, and then which
Yes.
one will work, and who can come up with other materials and use their imagination.
Yes, exactly. I mean, that was one of the things that I do, like for a sink and float experiment that the kids love, especially because of all the water that's used. I stick a whole lot of things in front of them and I ask them to choose what do they think will sink or float. And sometimes I stick a bottle of oil in front of them, or sand, or anything. It's just like you just put a whole bunch of things in front of them, give them a tray of water, like quite a deep tray of water, and get them to chuck things in. I even give them paint, like like poster paint. Get them to pour the poster paint. See what happens to poster paint in water. See what happens to poster paint and oil in water. And it's just fun. It's just such a lot. It's very messy, and most parents, when they come to my house, are very glad that they're coming to my house to do this, because they don't want their houses to be all messed up. So they're like, yes, of course, we're happy to do this. But it's just such fun, because the more mess and the more stuff that's created, the kids have more fun. And one of the things that I do with especially with ice, I don't know if has anyone tried lifting ice with a string? Anyone lifted ice with a string?
I think we did that. Is that when it fuses to the ice because the coldness?
Yes, it does. So you know what you do is you use a bit, you first of all you kind of give the kids ice, and then you ask them if they can lift ice up with a string. Now, normally, can you do that? You can't, right? You can't lift ice up with a string. So what you do is you put a little bit of salt on the top of the ice, so the ice then breaks, and then it freezes over the string. It sort of fuses back over the string, and then you can lift it up. So when we've done that experiment, so I get them then to put lots of salt onto the ice, and then to either paint the ice, or put food coloring onto the ice, and then they can see how the paint percolates into the ice. So the ice, because there's cracks in the ice, there's cracks inside, there's little fissures and things inside the ice, and so the paint actually goes into the ice, and it looks really pretty. So then once I've done that, I get them to put bicarb on top of the ice, and then they squirt it with a bit of vinegar, so it fizzes. So it's like it's a lot of fun. There's a lot of elements going on. So there's a lot of like chemistry and physics happening, which is great. And the children don't know they're learning chemistry and physics. It's only when they're older do they realize, they're like, oh yes, this is chemistry or this is physics. But initially, in the first stages, they're just having lots and lots of fun. They're just enjoying it. Lots of mess, lots of color, lots of lots of water splashing about, and and parents going like, we're so glad this is Sandra's house, not ours. So it's that sort of thing. But they're learning so much, which is the whole point of it. So anyway, shall we move on to another experiment?
Yes, please.
Okay. So now I'm going to show you a self-inflating balloon experiment. So what you need for this is, what do you think is at the bottom of this bottle? This is an ordinary bottle, but what do you think is the bottom of it?
Bicarb.
Vinegar.
Water.
Vinegar.
Who said water? No, not fizz.
Just
Yes.
water.
Someone said vinegar. That's right. It's vinegar. There's vinegar in here, and that's a balloon. So what do you think is in this balloon?
Bicarbonate of soda.
Yes.
Oh.
So this balloon is going to inflate, hopefully, on its own. Can you see that?
Yeah.
Oh wow.
So why do you think it's inflated?
Wow.
I'm going to use this. I don't have to blow balloons up in the future. It really hurts. Yeah.
Absolutely.
Yes. So why do you think it's
vinegar reacting
yes,
to
yes.
Made a gas.
It's the gas, yes. So you've got a lot of gas in here. Now, what would happen if you took that balloon off and you had a lit flame, for example? What would happen to the lit flame?
Will it ignite further?
No, because that's
Up.
you've got what type of gas is it? What type of gas is created? Do you know?
Inert.
It's carbon dioxide.
Oh.
So if you take
It will go
carbon
down. Yeah.
You'll go bang.
yes, if
No.
you take carbon dioxide and put it next to a flame, what would happen to it?
change
Oh,
colour.
yeah.
No,
Yeah,
it'll
flame.
just blow it out.
Yeah.
It'll
Yeah.
extinguish it
Oh,
because it's carbon dioxide, right? There's carbon dioxide in here.
Yeah. And no oxygen.
No oxygen, and a flame needs oxygen to sort of burn, right? But if you put carbon dioxide on it, it'll just sort of die out.
I'm very clever.
Yes, that's right. It puts out the flames, which is right. Someone said, right.
wow.
So, any questions on this one? Yes,
Yeah.
I mean, of course, different fire extinguishers use different because you can't always use the same thing for like because you have different types of fires. Some you have oil fires, so you cannot use water on an oil fire because as you know, oil and water don't mix, right? So you can't use so on an oil fire you'd have to use something like sand. And then you have foam for a different type of fire. I mean, there's different fires, you have different ways of putting it out. You can't just use standard water for everything. So, which is actually good to know, really, because if you're trying to put out an oil fire, it's never going to help if you stick water on top of it. But yes, any
People
questions?
are asking if it
Yes.
is just standard white vinegar.
Yes, it's standard white vinegar. You could even use the, what's it called? The other one, the brown one. I forget what it's called.
Apple cider vinegar.
Yeah, that's the one. Yeah, it's just ordinary vinegar. Just you can just get them in shops and things.
How long will that balloon stay inflated? That was my
It'll
question.
stay inflated like that for as long as I want it to stay inflated. If someone put a hole in it, then of course the gas will leak out. But it'll stay like this. I can just leave it and it'll stay like this for like weeks.
Oh wow! I was gonna say you can do a little competition in your setting, couldn't you?
Yes.
And see
Yes.
whose child balloon stays up the longest.
Yes.
Yeah.
I know it is good fun. I mean, the thing is because it's become airtight. You see,
Yeah.
it's completely airtight. The gas can't go anywhere. All it's going is going up. It has to go up, or if it has to come down, it'll go back into the bottle, and that's it.
Yeah.
And if it goes down into the bottle when and and there's still a bit of bicarb there. So each time the bicarb goes into the vinegar, there's another reaction, and then the balloon inflates.
So we had a question to ask. What is the quantity of bicarbonate of soda you put into the balloon?
Okay, so when I'm using, this is a 1.5 ml bottle. So when I'm using a bottle like this, then it's sort of like just about that much of vinegar. And I usually use like 1 teaspoon of bicarb. But you have to, it depends on the size of the bottle. If the bottle is smaller, then of course you use less vinegar and less bicarb. What you don't want to happen, especially when you're working with really small children, is you don't want it to suddenly take off, because it does. I've tried that. I've tried an experiment with older children, 10 and 11-year-olds, where I've put a lot of bicarb in there and a lot of vinegar in the bottle, and the bottle actually just goes like whoosh. And it's fun for a 10, 12-year-old, but not fun for a 2 or 1-year-old. They get scared. So you have to kind of gauge your audience and then see, you know, the size of the bottle. Plastic bottles are usually the best because obviously, you know, you can then bin them if you don't want them, or you could just give it to the children. I tend to give all my all the equipment that I use, I let the children take home, because then they can try it again at home, and they can show it to their, you know, their mums or dads, whoever didn't come with them, or to their siblings or to friends, and that's, you know, and that's how you kind of get children interested in science, you know, other children interested in science. So that's usually what I do. But yeah, so this is the self-inflating balloon. There's a lot of other experiments that I do with what's it called, with air. So there's another experiment, I don't know if you know, that normally a bottle or anything around us is full of air. Like, for example, this glass is full of air. So one of the experiments that I do is I show the children a bottle, and I ask them what is inside the bottle, and they say it's empty, but it's not actually empty because it's full of air. And then I show them how it can be shown visually by putting a funnel on the top, pouring water into the funnel. Now, if the bottle is well sealed on the top, so as in like water can come, this is called self-inflating balloons. I think someone just asked what this experiment was called. It's self-inflating balloons. So anyway, going back to the air experiment. So all you have to do is seal the top, but leave this bit open, and then put a funnel through. I don't have a funnel, so I can't show you that experiment, but I'm just going to tell you. And if you pour water through that funnel, you'll have a few drops coming in, but the water will not rush in. Normally, when you pour water into a bottle, what happens? It just rushes in, right? But if you seal it just very carefully so that no air goes out of the bottle, but a little bit of water can come in, the water will actually sit on the top of the bottle. It will not go in. There'll be no. It's simply because there's air in the bottle. I don't have a funnel. Others I could show you. It's such a brilliant experiment. I love that. It's in my book, by the way. So you could possibly do it. Again, it's just the same sort of bottle, and it's a great experiment. But I was going to show you a buoyancy experiment, which is also a very, very simple experiment. So I've got 2 oranges. What do you think I'm going to do with it?
Well, if it's buoyancy, are you going to put it in water?
Yes. So, but what am I going to do with one of them?
Heal it.
Heal it.
Yes. So again, water in there. So I'm going to put this one in there. What's happened to it?
It's floating.
It's floating. Now, what would happen if I peeled it? What would happen to this orange if I peeled it?
Is it going to sink?
Yes. Why do you think it'll sink?
Because it'll soak up the water. No.
The skin puts the weight on the make it lighter so it can float.
Yeah, so what is in the skin that's making it float? So okay, well, let's do it again, okay? So this is
air in the skin.
unpeeled
and
orange.
Oxygen in the skin.
What's happening to that? It's also floating, right? Can you see? Why do you think it's floating?
Just without skin.
Do you think it's going to sink? Or do you think it's going to I've only just peeled it.
I think it will sink eventually.
Yes. So why do you think one will sink and one will float? Why do you think this one floats?
Must be something in the skin.
The skin is almost like a wax around it.
Okay.
Skin
Something to do with vacuum and air.
Yes. So in the skin, if you turn it over, there are air pockets. There are air pockets in the skin. In each orange, so it protects the fruit. So things like lemons and various other citrus fruit are all protected by air pockets. Now, the other thing that you could do with air pockets is that when you squirt air and it's actually the oil from the when you squirt oil from an orange into a naked flame, what do you think happens?
It actually ignites.
It does ignite. Why do you think it sort of catches fire?
Oil.
Yes,
Oil.
it is the oil. Yes, because of the oil in and so that is also quite an interesting experiment to do with young children. I've done it. Obviously, you don't ever get a child to sort of get too close to it, but you can show it to them and show them what happens. So what I do is I do quite a few fire experiments with the children, but I always kind of tell them that they should always stay safe with fire because fire is quite dangerous, and they do understand that. So I always kind of get them to sit at one end of the table and I do it at the other end, and of course the parents are with them. But fire experiments are great for showing children because all the states are the states in nature, the fire, air, water experiments. I mean, fire is part of it, but you have to be safe. But this particular experiment is actually quite fun, where you squirt an orange peel into a flame, and there's a spark. It's like a little. It's really quite fun. There's a spark that happens, and you can see it. You can actually see it. I mean, I call it dragon's breath, and it's actually quite fun. And children again love that because again, fire is it's sort of it's scary, but it's also fun in that sense. But yeah, so that's one of the other experiments that I do. I do quite a few fire experiments, but again, you have to be very safe with the experiment. But yeah, so those were some of the experiments that I wanted to show you. And there's one more experiment. I don't know if it'll work. The other thing with experiments you must know is that sometimes experiments work and sometimes they don't work. And that's the whole point of everything, because in life things sometimes work and sometimes they don't work. But that doesn't mean anything. It doesn't mean it's the end of the world. It just means you need to find a different solution to it. And that's often how I deal with things like nothing in science is a failure, put it that way. That you're never wrong. It's you can't go like, oh my gosh, this is the end of it. There's always a solution. Some people come to it through a different way. You have to find your own way to come to a solution. So there are times when we actually look at experiments that don't work, which is actually quite good, just to show children that often, in fact, a lot of times, experiments in science do not work at all. And you have to just kind of keep going and keep trying to look at it from a different angle, different perspective, etc., etc. And it also helps. It helps children to think differently. It gives them that ability to kind of realize that, there's no right or wrong when it comes to science. You can always come to a solution through a completely different way. Someone would for example, we did this this is going back a few years. We did a robotic hand with straws and a paper plate. Now some children use thread to pull the straws down to make it into fingers. Some children use pipe cleaners. Some children wanted to use craft sticks, and each child eventually figured out how to do it. Some couldn't do it properly because they didn't know how to do it, but it didn't matter because eventually they learned a different way of doing it. So it's just everyone comes to the end conclusion through different ways, and it's absolutely fine. There's no right or wrong with science. So I'm going to show you this experiment, which may or may not work. It's called a bouncing marble. So, which does sound kind of funny because marbles don't generally bounce in that sense. but we're going to do a bouncing marble. Again, I'm just reusing the glass that we did. I'm going to cut, this is just a balloon. I'm going to cut the neck of the balloon like that. Okay. Oops. We've got that. And then I'm just going to open the balloon out. Can you see what I'm doing?
Yep.
I'm going to just open the balloon up and try and put it over the glass. It might work. It might snap. I don't know. Right. Oops. Quite tricky. But perseverance does pay in these things. Right. Hopefully it'll work now. So you just, so basically, see, it should be absolutely taut. So like really smooth. There shouldn't be any sort of little dips or anything in it. So can you see that? Can everyone see that?
Yep.
Okay. So now we've got a marble. So this experiment works. Sometimes it doesn't. I'm just going to drop the marble just there, and it should bounce for a few seconds. Did you see that?
Yeah.
It should just bounce for a few seconds. Oops.
Very cute.
Sometimes it just goes for longer than a few seconds. Depends on that. That's because that's breaking. Can you see? That's breaking.
Yeah.
It's one of those experiments that sometimes work and sometimes doesn't work. But yeah.
No, that's been amazing, Sandra. I know we are running out of time, and I know everybody here has to get back onto the busy floors. So, Sandra, just from our side, we were gonna have a Q&A session, unless there's someone who's got an urgent question for you. It's been quite an interactive session as well, which I think I have loved, and I'm sure everybody else has as well. So, thank you so much.